Hi all, welcome to first part of the video lecture on ER to relational model mapping. So as you already know, what is ER model? So it's a popular conceptual data model, right? Conceptual data model. So this is something we covered already. So we saw how from the given set of descriptions of the mini word, how one can come up with the ER model, I mean ER diagram. So what is entity, what is relationship, what are all different cardinalities of the relationship, right? The participation constraint, many things we discussed that time. Okay, so hope you remember. And then we moved on to the next level of design, that is this relational model, and which is a popular representational or implementational model. So it is very close to the actual implementation of the database. Okay, so we independently studied what is this ER model and how one can come up with it, and also this relational model. So there it's what is the formal definition of relational model, as how it is related to the mathematical concept relation, and different constraints, integrity constraints, referential integrity constraint, the concept of keys, primary key, foreign key, many things we saw there. Now it's time for us to understand how this mapping can be done, because so this ER model is something like the plan of a, so it's analogous to plan of a building, right? So that time, so by which you can communicate with the user and all, but once you have this ER model, from that ER model how you can move on to the relational model. So that is a flow, right? So if you are independently developing relational model, that is meaningless. So first you will be developing ER model, and that ER model you are supposed to map to relational model. So when it comes to ER model, we have entities, right? So what about how you will be representing this entity in the relational model? So you will be representing it with a relation, okay? And similarly, this entity is having attributes or properties, right? So those things will be coming as the column heading of this relation. So like that, everything we will map. And the relationship itself, we have 1:1 relation, 1:n, many to many. So how these things are handled in a relational model. So these are all the things we are going to see in detail. So let's start the concept like relational database design using ER to relational mapping. So right now we know how this relational model can be designed independently, but we don't want it. So first we will be designing this ER modeling, and once ER modeling is something finalized, we can do a mapping, formal mapping to the corresponding relational model. So that is what we are going to see. So the procedure to create a relational schema, so which is otherwise called as the logical schema or representation model or implementation model, many names we know, right? So from an entity relationship schema, which is a popular conceptual schema, is explained through a systematic ER to relational mapping algorithm. So this algorithm, there are 7 steps for the basic ER to relational model mapping. Then further steps are there for mapping the enhanced ER model to relational model. But anyway, this enhanced ER model you are not studying as per your syllabus. So it is enough to know this ER to relational model mapping algorithm. Okay, so some 7 steps we will see one by one. The company database example, hope you remember previously also everywhere we are taking this example, company database, where we have a database for the department, employee, dependents, right, projects, like that. So that example is used to illustrate the mapping procedure. So the company entity relation schema and the corresponding company relational database schema are shown in the subsequent slides. So this is something we already covered in detail in our first module, that is the CR model in detail. Okay, so finally from the descriptions of the mini world, you are supposed to draw something like that, and I hope you remember all these concepts. This double line indicates total participation, and what about this n means n employees are working for a department, and those I hope you remember. What is this? Is a derived attribute, like that multivalued attribute, all those notations, everything you are familiar. Now from this diagram, how one can map to something like this. So this also you are familiar independently, like what is a relational data model schema, right? So this is name of different schemas, and these are all the attributes, and here you can see the underlying things are the primary key, and this arrow corresponds to foreign key, and hence referential integrity. Okay, so that about it. Now we are going to see how from this ER model we will be obtaining something like this. That is a whole agenda. Okay, so one by one we will see. So we will start with the first concept. I mean, so it's a step-by-step procedure or systematic algorithm we are going to see. And this first step of the algorithm is like how one can map a regular entity into relational model. You know, these are all regular entities. This here, this employee is a regular entity, department is another one, right? Department, project, dependent. So here we have four regular entities and how these regular entities can be mapped. Then we will see how this relationship can be mapped. Okay. Sometimes we have this weak entity. So this is a regular entity. Okay. So this is a regular entity. So this is regular, the normal type of entity. But if we are looking at this entity, it is a weak entity, right? So we have to see how this regular entity can be mapped, also how this weak entity can be mapped. Okay. Then we will see what about mapping of the relation, then how to deal with the multi-valued attribute. Like that, one by one, we will discuss the concept. Okay. Hope you get an idea. Yeah, that about it. But let me just quickly tell you, it's very easy. There is nothing more in it. When it comes to a regular entity, what you have to do, you have to convert this regular entity into a table, something like this. So you can convert it into a employee table or employee relation. And what you have to do, so what are all the attributes of this entity? So that will be the column heading here. Okay, so SSN is there, then birth date is there, like that. Okay, now when it comes to a composite attribute like this, each individual attribute will get a column here. Like first name, you will get a column. Okay, like that, let me explain. So this will extend, then there is a column for middle initial something, last name. Okay, then salary, sex. So like that many entries will come. Okay, now what you can do is, what about the primary key? You know, that key concept we have in ER model and relational model. But in relational model, we discuss that key concept in much more detail, like what is a key, what is a super key, and how it is different from a key, which is a minimal super key. And what about the candidate keys, and what is a primary key, and what you can call about the remaining candidate keys. So like that, many things we explained there. And so, you know, basically when it comes to relational model, what we are interested is a primary key. See, here there is only a single key SSN. You can make the same one as primary key here also. But if we have more than one key is identified by the ER model. Okay, so for example, so here it's this department is having name which is unique as well as number. Both are found to be key in the sense they are unique. Now it's up to the discretion of the designer, like either he can go with the department number as a default primary key for the department table. So when this department number or something number becomes the primary key, this time becomes the alternative key, or it is a unique attribute, just a unique attribute, but it is not a key, something like that. So that one will randomly pick. So that about it. But similarly, every table will be converted, like this dependent table. So department table, when you convert, but here you have to note down, there is an entry for name, there is an entry for number, like that. Okay, but there is no entry for this location because it is a multi-valued attribute. It will be handled differently, in the sense there will be a new relation for this, and we will see how it can be handled. Okay, similarly, so that about other entities also. Hope the concept is clear. Now when it comes to weak entities, so this we will show as the second step of the algorithm. So this is something that you have to handle differently. So this weak entity also, let me just quickly tell you what we are going to do with the weak entity. So here weak entity, we will make all entries and we will try to map it to a relation, right? Okay, now the thing is that, you know, in weak entity there is no key, right? So what we have is a partial key which may repeat definitely. So within a say particular employee, if you are looking at the dependents, they may have a different name, but it is not the case in general. Okay, so what you have to do is, now this weak entity is being identified by this particular identifying relationship, and it is being related with a strong entity. So without the support of this strong entity, this weak entity can't exist alone, because first of all there is no key at all. Okay, and it always depends on that particular reference to the employee. So whenever I am saying that I know a particular dependent name, so on, so you have to see from the organization point of view, you can't differentiate that person. You have to clearly say this particular person is a dependent of this particular employee and having this relationship, something like that. So that is a thing. So for making that what I can tell you, so that identification possible, So you should link this weak entity with the strong entity by taking the key attribute of the strong entity, that is SSN. So if you want, you can write it as SSN, or you can put it like some employee SSN. You can give a different name also if you want. Okay, and that you will make us see foreign key of this particular. Hope you remember what is foreign key. Okay, so this field will be referring to this one. Okay, something like this. So this will act as a foreign key, and that will refer this main employee. So we just say dependents don't have any existence without referring to a employee. So dependents, they are meaningful only when you link them with a particular employee of the organization. Otherwise, from the organization point of view, that particular person is of no relevance, right? And foreign key concept also, now the thing is that how you will choose a primary key for this one. So typically the convention we are using is this foreign key and the partial key of the original relation together becomes the primary key now. Okay, because if you are looking at that employee SSN alone, same employee may have more than one dependent. So ESSN alone is repeating. Okay, and name field also, for a particular employee name is not repeating, but across different employee name is repeating. So name field alone will repeat, ESSN alone will repeat, but ESSN and name field together is not going to repeat. So the rule is like from the referencing table. So the weak entity will always depend on some other table. So it is supposed to refer that what is that other table called employee table, here is called as the owner entity. Okay, so this is the owner entity for this particular weak entity dependent. Okay, or it is identifying entity, and this relationship is called identifying relationship. Okay, now the primary key of the owner entity should act as the foreign key in the weak entity, particular weak entity, and the this particular foreign key and the partial key of this weak entity together makes the key structure. I mean, together becomes the primary key for the particular weak entity. Okay, so hope you got the concept. Anyway, I'm removing all those things. We will see the theory. So this is what we are trying to see. So finally, when you are mapping for every entity, you are supposed to have a relationship. Okay, so a relation or a table. Okay, so that mapping rules are we are going to see. So the first thing is talking about the mapping of a regular entity type. So what you have to do, so this is just a regular entity in the sense it's not weak entity or something else. Okay, so for each regular strong entity type, so by default they are strong, capital E in ER schema, create a relation capital R that includes all the symbol attributes. So first of all, what you are doing when you are mapping this entity to a relation, you are mapping all the symbol attributes. So all the symbol attributes you can simply map. Okay, now when it comes to composite attribute, what do you have to do? So symbol attribute you can map directly, but when it comes to symbol attribute you can map directly. When it comes to composite attribute, you have to take each and every components of the composite attribute, right? And that you have to store separately. So hope you remember, same thing I also taken, like here name is composite attribute. So when the as far as this entity employee is concerned, but when you are mapping this entity employee into a relation, SSN will be a column, birth date will be a column. Similarly, first name is another column, middle initial and the last name. So like that there will be 3 columns just for this name attribute. Okay, so and they will be stored accordingly, and these things are automatically happening. Okay, so that is the way, because in relational model we don't want a composite attribute or multi-valued attribute. Hope you remember that is the assumption of a basic relational model or flat relational model, right? So that is something we will follow, right? So that about it. Now these yeah, so that about the composite attribute. Now what about the key attribute? Because in the original entity there is a key, right? So that is simply underlined. And now when you are mapping this particular original entity one second. Yeah, so you have an original entity. So if the chosen key is composite, then the symbol attributes we will make. Now what about the key? That is what we are discussing. The original entity will have a key. Try to make the same one as the primary key of R. Now, if the original entity is having more than one keys, then one of the key, maybe arbitrary decision, okay, will be acting as a primary key in the relation, corresponding mapped relation. So, okay, that about it. Now, if the chosen key is composite, then the set of all symbol attributes that form it will together form the primary key. So it is something like that. Everywhere that composite attribute is not allowed. So whenever this, whether it is a key or a normal attribute, this composite attribute is coming, you decompose and store it. Okay. So because by default, this relational model is not going to support composite or multi-valued attribute. Okay. Now, if multiple keys were identified for capital E during the conceptual design, the information describing the attributes that form each additional key is kept in order to specify additional keys, that is unique keys of the relation. You know, one of the key attribute we will make as primary key, and rest of them we will call as unique keys or alternative keys. So that also you have to note down, but you are not going to mention them specifically. So that you have to note down in the original relation, what I mean entity, what are all the keys, make one of them say arbitrarily as a primary key, and remaining them you keep as a unique key. Okay, you should have, so how it is to be, I mean in the relation model and all, when during that schema definition we will define such unique keys. Okay, so we will see that. Now the relations that are created from the mapping of entity types are sometimes called entity relation, because these relations are nothing which are newly created, they are mapped from an entity, so we can call them as an entity relation. Now this mapping of weak entity also I told you already, because corresponding to weak entity we have an identifying relation, just look at this example, and a strong entity at the other side, and the relationship is something like a one to many. Okay, so I mean many dependents a single person can have, so all those things you know. Now when you are mapping this, all the simple attribute will be there in the final in the relation corresponding to this dependent table, and also from this employee table, which is a owner entity, take the primary key and make it as the what called foreign key in the dependent table. Okay, something you have to do, and this particular foreign key and the partial key of the dependent table together is going to act as the primary key for this particular weak entity. So these things you have to keep in mind. So that about it. So in a, if a weak entity type, so what is a weak entity type? Basically it is not having a key, right? So that is the issue we are having in the ER schema with the owner entity. So so this is my weak entity, say W, and the owner entity is found to be some E. Okay, so create a relation R that includes all symbol attributes of this given relation. Okay, so so that about it. So simply all the normal symbol attributes are mapped into this relation. I mean the relation correspond to the weak entity. In addition, include all foreign keys of R, the primary keys of the relation that corresponds to the owner entity type. So we already seen that from the owner entity type we are taking that SSN and we are making it as the foreign key in this particular dependent table. So in a different table it will be different. Anyways, hope you get it. So put it as a foreign key, and also the primary key of this R, I mean newly created relation, is a combination of the primary keys of the owner and the partial key of the weak entity type W, if any. So you understood, right, why this assumption is taken. Owner entity is having one partial one primary key, which is now you copied into this dependent entity, and you are calling it as a I mean foreign key, right, in that dependent table, so by which you can make reference to the owner entity. Now this newly added foreign key, which is the primary key of the owner entity, plus the partial key of that particular entity we are interested, together will make the primary key of the corresponding relation. Hope you got it. So I give an example also. Now if there is a weak entity type, so now it may depend multiple times. Like I have a weak entity E2 whose owner is also another weak entity. So E2 will be referring E1, E1 may be referring someone else, right? Then this E1, which is top in the hierarchy, something like that, should be mapped first. Then only you can start doing E2's mapping. Okay. So E2 to determine its primary key first, something like that. Okay, so that is the order we are expecting. Now it is common choice. It is common to choose. Sorry, it is common to choose the cascade option. Hope you remember, whenever you are doing on delete cascade, even means whenever you are deleting some information, all the information in the original table should be deleted in a cascading manner, right? So the same thing is applicable for update operation also. So something like that we can use here. It is common to choose the cascade option for the referential integrity referential triggered action for the foreign key in the relation corresponding to the weak entity, since a weak entity has an existence dependency on its owner entity, right? So hope you got it. So whenever you are doing say on update or on delete, you can just mention cascade option, so that will be a good thing for you. Yeah, so that is how you can deal with this deletion and updation when after this kind of a mapping. Yeah, that about it. So what we discussed here is the first step of the algorithm, say mapping of the regular entity. So it is very clear, right? So that entity will be mapped, and attributes are also mapped, because yeah, that about it. And the composite attribute, how you are dealing with multi-valued attribute, what you have to do, that we will see. But composite at least you got. Now mapping of a weak entity which is not having a key of its, right? So what you have to do is, you know, so you can just follow this procedure, right? So from the owner entity, take the primary key and make it as a foreign key in this one, like that, all those steps you can follow. So that about it. Now actually we have a step number 3, 4, 5, 6, 7, like there 7 more steps are there. So only step up to september step number 2 is what we discussed now. Yeah, thanks for watching.